So everyone knows what framing is. It's the assembled lumber that gives support and shape to a house. They look at a partially built house, see that tangle of wood, and say, yeah, that's the framing. But most people's knowledge of framing stops right there. They couldn't name many of the individual components that they're seeing or tell you what those pieces are for. I've always believed that this puts them at a disadvantage in contracting situations. Pretty much every remodel and new build is going to require new framing. And extensive repairs are also going to involve framing as you deal with issues like rot and decay. In these situations, you want to be able to understand what your contractor is telling you, and the first step is understanding terminology. So in this video, I'm going to quickly run you through what all those individual framing members in a house are called. We're going to work our way from the bottom up, going from the foundation to the roof. And along the way, I'll even explain a bit about what these members do. And that's coming up next on the Honest Carpenter Show. Okay, let's get down to foundation level. Before framers show up, masons have either built up brick and block walls or poured concrete foundations. In either case, they give us a level base to build off of. In most houses, the first framing member we install is the mud sill or just the sill. This little known piece provides a stable layer for all the framing above it to rest on. If untreated wood sits on masonry, it can rot because masonry always has a moisture content. So the mud sill is made of treated lumber that isn't prone to rot. So it acts as a buffer between damp masonry and all the dry framing above it. The mud sill runs the entire perimeter of the foundation and is almost always tied down with anchor bolts, which prevent the house from lifting up when strong winds blow. The next layer of framing is typically the joists. Joists create the floor structure of a house. They're long pieces of lumber turned on their edge, which are then supported at various points from below. Joists span open space, acting as sort of a bridge across long distances. They give us something to walk on in the form of floors and something to hold weight above our heads in the form of ceilings. Joists used to be just dimensional lumber, like wide, flat pieces of solid wood. But in recent years, engineered lumber has partially replaced them. I-joists are modified I-beams built out of long pieces of strand board and solid lumber caps or flanges. I-joists are cheap, stable, and very versatile. And they often contain pre-cut knockouts that you can run utilities through, like ducts and wiring. This makes later construction phases both easier and cheaper. You still see a lot of dimensional lumber on job sites, especially in outdoor structures like decks. The outermost joist in a floor or deck is often called the rim joist or the band, depending on application. Other joists pair up with it or run into it. Sometimes joists are even supported by another horizontal framing member called girders or beams. Beams tend to be bigger, stronger pieces of lumber that act as a spine for joists to sit on. They're sort of like super joists for other framing members. Sometimes joists even run straight into them and are held on with hardware. Girders and beams are sometimes made of dimensional lumber grouped together. Or more commonly, they're made from LVLs, laminated veneer lumber, a type of engineered plywood that is very strong and comes in really long pieces so that they can bridge longer spans. Now, girders and beams also need something to sit on for support. Sometimes they rest on masonry piers, like in a foundation. Other times, they rest on columns or posts. These words, column, post, are sort of catch-all terms for a vertical support. Sometimes they're made of hollow steel, like this one I installed beneath an overspan girder in a garage. Other times they're made of wood, like the very common porch post. I installed these 6x6s beneath an under-supported deck. And on porches, you'll see wrapped columns holding up the beams that support the roof and ceiling. Sometimes these columns are very decorative, but they're still structural. But altogether, columns and posts transfer loads from a beam or girder down to somewhere lower in the foundation or another support. Alright, so with all that structure in place, we can move up from the lowest parts of the house. After the joists have created the floor structure, they get covered with subfloor. Subfloor is sheets of plywood or strand board with tongue and groove edges. Pieces sort of interlock to create a stable surface on top of the joists, and this covers the full perimeter of the floor plan, right out to the edge of the structure. Everything above this point sits on the subfloor, and that includes the walls themselves. As everyone knows, framed walls are built with studs. This word is, of course, an endless source of amusement. But stud is really just a blanket term for pieces of lumber stood up on their ends to create the vertical structure of our homes. They're most often in the 2x4 or 2x6 dimensions. Studs can stand individually, spaced out either 16 or 24 inches center to center, or they can be fastened together in groups known as stud packs. These packs sort of act as makeshift columns in our walls. They carry heavy point loads from somewhere above and transfer that weight down to a safe point below. But studs never actually touch the subfloor. Instead, they sit on another horizontal piece of wood known as a plate. A plate is basically just a stud laid down on its back. It's virtually identical to a mud sill, except that it's not treated because it's not in contact with wet masonry. This is just kiln-dried 2x4 or 2x6. So you have a bottom plate beneath the wall, and you have top plates at the top of the wall. Top plates are typically doubled up for strength. We call them double plates. Adding top and bottom plates to vertical studs lets us build our walls laying down and then stand them up into place. It turns the whole wall into a rigid unit that acts as one piece. Studs and plates are virtually continuous in a wall, except where they're interrupted by doors and windows. These openings get special framing, and that framing has a complex system of names and functions. For instance, you've probably seen these pieces of solid wood facing outward above an opening. These pieces are called headers, and they're very important. Doors and windows create hollow space in a wall, which means that studs aren't there to support weight from above. So the headers transfer the weight that would be in that space out to the edges of the opening. Really, they act the same way that a beam or girder does to carry weight over a span. They're like a bridge that creates a safe hollow space for the door or window to sit inside. Sometimes headers are also made up of LVLs over longer spans, like garage doors where they need to bear more weight. The ends of the header sit on pieces called trimmer studs or jack studs. Then they're enclosed by taller pieces called king studs, which extend all the way up to the plate. Empty spaces above a door or below a window are then filled with what are known as cripple studs, just little short pieces that provide support and create nailing surface for drywall and cladding. The bottom horizontal piece in the window opening is called a rough sill, and the entire framed opening of a door or window is known as the rough opening. Again, all this structure bears the weight around these openings so that doors and windows don't have to. There should essentially never be any weight on a door or window. They just sit in a hollow opening and do their job. You'll also see little horizontal sections of wood in framed walls. These pieces are known as blocking, or in some countries, nogging. Blocking serves many different purposes. In tall walls, it prevents studs from bowing or twisting. In some cases, it provides a fire block, which prevents fire from traveling up the stud bay like a flue. This slows the fire down so it can't leap between floors. And in places like bathrooms and kitchens, blocking is installed turned up on its edge. This provides solid wood to mount towel racks, cabinets, and other fixtures to. You really see various types of blocking all throughout a house. That covers much of what you'll see in a single bottom floor. So, moving up, we come to staircases. Stairs used to be built entirely from notched lumber known as stringers. In some cases, especially outdoors, they still are built this way. But many modern interior staircases are built in factories as single enclosed units. These units are ordered beforehand based on accurate measurements and pretty much just get installed like a ramp. The vertical pieces of staircases are called risers, and the horizontal pieces are called treads. They may be attached to frame walls at either side for extra support, or rest on smaller frame knee walls beneath them. Knee walls are just short wall sections, typically under 3 feet. Sometimes they support something, other times they're freestanding. I'll mention here that the word header is also used to describe a piece of framing that opens up a hole in a floor or ceiling. Just like a small girder, a ceiling header carries the weight of several joists by transferring their load out to other parallel joists. This lets you create openings for pull-down attic stairs, dormers, staircases, you name it. So that's a second definition for headers, and it serves a slightly different function. These headers are installed in horizontal floors as opposed to vertical walls. Okay, continuing upward. Higher floors in a house are built much like the first floor. Joists sit on the top plate of the wall below. Subfloor covers those joists, and the next frame wall sits directly on that subfloor. It's pretty much exactly the same floor to floor. Taller houses may require more beefed up framing, especially on the bottom floor. But terminology-wise, words are going to have the same meaning everywhere. Things only get different again when you finally get to the roof. Roof framing is a complex topic because things stop moving in 2 dimensions and they start converging in 3 dimensions. In traditional framing, roofs are made up of rafters. Rafters are a lot like floor joists, except they're set diagonally at a fixed pitch. At the bottom, rafters sometimes sit on the top plate of the wall below. Other times, they sit on yet another floor structure in the attic. Rafters typically travel upward and converge at a ridge board. This is a fairly tall board that gets sandwiched between rafter peaks. In houses with gables, the ridge board runs all the way out to the exterior wall and sometimes beyond. In houses with contoured roofs, the framing gets more complicated. To create an outside corner, a hip rafter descends from the ridge to the corner of a wall. To create an inside corner, a valley rafter does the same thing. So these roof contours are simply called hips and valleys. Shorter rafters that meet a hip or valley are called jack rafters, but rafters that go all the way to the ridge are called common rafters. On gable roofs with an overhang or an eaves, the suspended rafter hanging out in the open air is called the barge rafter. Down at the lower point, the projecting end of the rafter is called a rafter tail. These are usually tied together with a subfascia. And in houses that will have an enclosed soffit, the little backstrap piece of framing is sometimes called the lookout. Now that's a traditional roof, but many newer homes and smaller commercial buildings aren't necessarily built this way anymore. Instead, they're built with something called roof trusses. A roof truss is an engineered, pre-assembled unit that creates the shape and structure of a roof. In truss roofs, multiple trusses are installed side by side, like rafters, and braced together until the roof sheathing can go on. Trusses are really kind of miraculous. They're made of much skinnier, shorter pieces of lumber, pinned together with spiky metal plates. Altogether, they create sort of a web, and that web is very strong. In fact, it's so strong that most truss roofs don't even need load-bearing walls beneath them. They act like a big girder spanning from one outer wall to another. Trusses are also sometimes used for floor systems. They're very strong, they speed up construction, and they cut down on the amount of large dimensional lumber that we used to need to build houses. So you've got traditional roofs with rafters, or you've got trusses. Kind of two different worlds. But after all this framing is in place, our structure is essentially created. And yet, it's still not stable. Both the walls and the roof will still need to get sheeted or sheathed. Sheathing is a layer of plywood or strand board that covers the entire framing system from the outside like a skin. It's the layer beneath the house wrap and the siding. Sheathing is very important, and it often does more than just close the house in. It also prevents the house from falling over. But that's a topic for another time because it's complicated and it deserves at least one video of its own. This video is about framing, and you've just heard about many, if not all, of the important framing members in a house. So, what did you think? Did you learn something new from all this terminology? Or are you an experienced builder with something to add or even correct? Let me hear about it down in the comments. I'm always up for getting outside advice. If you get a chance, check us out at thehonestcarpenter.com, where we consult with homeowners and property investors nationwide about a range of important issues. As always, thanks for watching. Be sure to check back in for more videos coming up soon. And please consider subscribing and hitting that little bell button to turn on notifications. That way you'll know the moment we post something. I'm Ethan James with thehonestcarpenter.com. I'll see you next time.